Welcome to Spring LIB.
We're told that a boat leaves a dock at 2 p.m. and travels due south at a speed of 20 kilometers per hour, and another boat has been heading due east at 15 kilometers per hour and reaches the same dock at 3 p.m. We're asked at what time were the boats closest together. Now let's consider the position of the dock as the origin. So the dock is at the point 0, 0. Now boat 1 is moving south at a speed of 20 kilometers per hour. So the position of boat 1 is 0, negative 20 t, where t is in hours. And at 2 p.m., boat 2 is 15 kilometers due west of the dock. And because it took the boat 1 hour to reach the dock at a speed of 15 kilometers per hour, its position then the position of boat 2 at 2 p.m. is negative 15, 0. And we're told the position of boat 2 is changing with time because it is moving east with a speed of 15 kilometers per hour. Therefore, its position at any time, t, this is negative 15 plus 15t, 0. Now, since we know the positions of both boats at any time, we can use the distance between 2 points rule to write a function of the distance between these two boats. So this distance, which I'll call little d, this is the square root of, let's see, the x-coordinate of boat 2, which is negative 15 plus 15t, minus the x-coordinate of boat 1, which is 0, squared, plus the y-coordinate of boat 2, which of course is 0, minus the y-coordinate of boat 1, which is negative 20t, so this is positive 20t squared. And this simplifies to well, this sort of is a tricky question because, in fact, our function d is minimized when the function f, which is d squared, is minimized. So we can simplify this problem. So f as a function of t is negative 15 plus 15t squared plus 20t squared. And if you FOIL this out, this is 625t squared minus 450t plus 225. So now to find the shortest distance, or the minimum of f, we'll take the derivative of f and set it equal to 0. So f prime of t is a 2 times 625. This is 1250t minus 450 equals 0. And so we get that t is equal to 450 over 1250. or t equals 9 over 25. Now, using the first derivative test, we have that if t is less than 9/25, then it follows that f prime of t is less than 0, and that t is greater than 9/25, then f prime of t is greater than 0. Therefore, by the first derivative test, it follows that f has a minimum at t equals 9/25. Now, what is this in terms of time? Well, this is in hours. We want to write this in clock notation, I guess you'd say. So, as an analog time. Well, 9/25 hours, this is the same as, well, there's 60 minutes in 1 hour. And so this is how many minutes? (108/5) minutes, which if you divide, we get 21 plus, then we have a remainder of 3/5 minutes. Now, what is this 3/5 minutes in terms of seconds? Well, 3/5 minutes times, once again, we have 60 seconds per 1 minute. This is 36 seconds. And so t, our time, is equal to 21 minutes and 36 seconds. So adding this to the start of the journey at 2 p.m., it follows that the boats are closest at time 2:21:36 p.m.